The name of this lesson is Similar Triangles. It's a little long, so it's probably going to be in two parts. But we just finished talking about similar polygons. And we said polygons are similar. They have the same shape, but a different size. The corresponding angles are congruent. The corresponding sides are proportional. The ratio of the corresponding sides are equal. And the ratio of the corresponding sides is called the scale factor. Okay, and so triangles are obviously polygons, so all of those rules uh, are true in respect to triangles. Now we're going to look at some special rules for triangles. Okay, the first one is called angle-angle similarity. So just very similar to when we were proving triangles congruent, we did not have to prove every single thing. We had some postulates that allowed us to prove congruency without knowing everything about the triangle. The same thing is true for similarity. If two angles of one triangle are congruent to two angles of another triangle, that is enough information to prove that the triangles are similar. So let's look at an example here. Can these triangles be proven similar by AA? Now they have drawn them over here to the side for you separately, which is what you might need to do yourself at some times. But in this picture here, we see a right angle, and then we see these vertical angles. And so vertical angles, even if they didn't draw them, that's enough. We see that we have two angles in both triangles that are congruent. That is definitely enough to prove similarity. And then when you write the similarity statement, you have to put it in the proper order, lining up the angles that are congruent. So if I say ACE is congruent to, the angle that's congruent to A is D, so I start with D, B, E. Okay, and the quick check to the right, these symbols here show that those sides are parallel. And so we have, anytime you have parallel lines like this, again, we have these parallel lines cut by transversals, which mean that these angles that are kind of across from each other like that are going to be the ones that are congruent. So let me clear this up. But so this angle is going to be congruent to this angle, and this angle is going to be congruent to this angle. They kind of wrote this on the other side. I would draw them exactly in the same orientation. So F lines up with J. So I would put my J down here, and I would put my K here, just for writing my statement. Yes, we have angle-angle similarity, and if we put F, G, H, the order of the next one has to be J, K, H. Okay? So now we're going to look at another example, and we're going to solve for a missing measurement given that these triangles are similar. So let's see, they give us that AB is 4, and they have drawn these over here for us as two separate triangles. And you notice that they told us that these lines were parallel, and so we know that B lines up with C and A lines up with D. Okay, so my 4 is here, CD is 8, AE is 3x plus 1, and ED, I'm sorry, I wrote that the wrong way. Let me clear that. This is 8, 4, ED is x plus 12, and AE is 3x plus 1. Okay, there's more than one way to do this, but what I notice is I have a 4 and an 8. And so if these are similar, I see I have a scale factor of times 2, because 4 times 2 is 8. So one way to solve this is any side here, if you multiply it times 2, you get the corresponding side. So I would say 2 times 3x plus 1 is equal to x plus 12. And then you would get 6x plus 2 is equal to x plus 12. 5x is equal to 10. And x is equal to 2. Now they ask for AE, and so just substitute 2 in here and you get 7. And then for DE, substitute 2 in here and you get 14. And you can see that 7 times 2 is 14. Now there is another way to solve this. If you don't like using scale factor, if the scale factor is a fraction and you don't want to mess with it, you can always set up a proportion. And so that would be 4 over 8 is equal to 3x plus 1 over x plus 12. So you just take 4 and put it over the corresponding side. 8 is equal to 3x plus 1 over x plus 12. And you can cross multiply, and that's just another way to find the same answer. Okay. Now we have another rule, and this is side angle side similarity. So if you have two triangles, and if one pair of corresponding angles is congruent, and the sides including the angle are proportional, that is also enough information to prove that the triangles are similar. So you have to have two, so they show us this side here is proportional to this side, and then this is proportional to this, and we have the angle in between those sides. So let's look at our example. Can these triangles be proven by side angle side? So what we look for is we first have to have a pair of congruent angles, which we have, and then we're going to take this side and see if it is proportional. So 4 over 6 with this side and this side. More than one way to do it, but this looks like a pretty easy way because you can cross multiply and see 36 is equal to 36. And so yes, we have enough information because we have one pair of congruent angles and the sides including those angles are proportional. So we can say triangle MLN. The order doesn't matter on the first one, but it matters on the next one. So now I have to say PQR. So those two triangles are similar. Let's look at the next example. Side, side, side similarity. Okay, so if you have, let's move it up just a little bit more. Okay, well, side, side, side similarity. So if all three pairs of corresponding sides of two triangles are proportional, that is also enough to prove similarity. So if you have two triangles, now for this one thing to keep in mind is you have to have measurements on all three sides of both triangles and then set up proportions and see if they are the same. Or in this case, let me scroll up a little bit now. Again, we can use proportions or we can use scale factor. And the one thing that I notice right away is I have a 3 and a 9. Well, 3 times 3 is 9. I have a 4 and a 12, and 4 times 3 is 12, and 5 times 3 is 15. So this one here, I can see that I have a scale factor of times 3. So that's, I know I have side, side, side similarity. So if I put STU for the first one, I have to put XWV for the order of the following one. Okay. Determine if the triangles with the given side lengths are similar. If the triangles are similar, what is the common ratio? Let's not use common ratio. Let's use scale factor, okay? Or just use the term scale factor. Okay, the measures of ABC are 4, 5, 7, and the measures of XYZ are 16, 20, and 28. They don't give us a picture here. So the one thing is these look like they're written in the same order, but I can notice the one below it is not. So be careful when you look to set up or look for a scale factor that you're taking the smallest length here and lining it up with the smallest one over here. And is that equal to 5 over 20 and 7 over 28? Again, on this one here, I notice that I see a scale factor right away because I know that 4 times 4 is 16, 5 times 4 is 20, 7 times 4 is 28. So, or you can put these all in your calculator and you'll get 1/4. Yes, they're similar because we have 3 pairs of sides that are proportional, and so the order would be the same order that it's written here. A, B, C, X, Y, Z. Okay, please pause and see if you can do the quick check yourself. Okay, looking at this, the one thing I notice is that the first number I have over here is 3, and that's the smallest, but the smallest number over here is 2. So we want to make sure that we line up the 3 with the 2. The 5 then would go with the 2.5, and the 6 would go with the 3. And so I know that if you look at these, and I kind of 3, 2, 5, 2.5, 6, and 3. Okay, yes. So I'm looking at these and I can see that this is not going to be proportional. Think of the first one. 2 times what is 3? That's like, it's certainly not. If you look over here, 2.5 times 2 is 5. 3 times 3 is 6. So 2 times 1.5 is 3. So those are not proportional, or you can put them in your calculator and see that the first one's going to be 1.5. This is going to be 2 and 2. So we don't have to worry about putting them in order because they are not going to be proportional. So these triangles would not be similar. Okay. So we can do one more. Are the 2 triangles similar? If so, state how and write a similarity statement. They've drawn the pictures over here to the right for you, but what you need to see is that we have this triangle, and then we have this triangle. And so what is apparent is that this angle X is the same angle in both of the triangles. So even though they only gave us this one measure of 80, we have angle-angle similarity because the X, whatever the measure it is, it's the same in both. So we could say that triangle XYZ is similar to XVW. Okay, I'm going to go ahead and stop this video now, and this will be the end of part 1, and we'll pick it up in the next video with part 2.